An error occurred. Oh, we are live. Well, according to StreamYard, we are live. Welcome back, everybody. Really glad to have you joining us once again for another edition of App-Driven Analytics, the live stream. Today is the third of a three-part series. I'm going to turn this music down just a little bit. And welcome back, Jay Runkle. How are you, sir?
I'm doing great. I'm glad to be here.
Fantastic. Well, it's good to see you once again. This is the third week. 3 live streams over 3 weeks, all about app-driven analytics. We're getting really deep into app-driven analytics. And I want to welcome everybody that's joining us on the LinkedIn and the YouTube stream. Welcome to the MongoDB Podcast Live. There are other versions of the podcast, by the way, while we're waiting for folks to join. You can check out the MongoDB podcast on all major podcast platforms, including Apple, Google, and Spotify. And I'm kind of concerned that we're not seeing anybody coming into the comments. Let us know where you're coming in from. Let us know that you're here, that you can hear us. Let us know where you're joining us from. Aloha. Oh, here we go. All right. Hail SQL. Ashir, how dare you? Hey, do you know that we support SQL? Look at this guy.
We're actually going to use SQL today, so maybe he's in the right place.
Yes, we are. Yeah. Ashir, you are in the right place. Stick around. And speaking of sticking around, I want to invite folks to stick around because that shirt you've got on, Jay, that's a highly coveted item. That is a MongoDB Podcast t-shirt. If you want to win a t-shirt just like the one Jay has on, stick around. We're going to be having some trivia. We're going to ask you some questions and give away some opportunities to win a MongoDB Podcast t-shirt. So if you want to learn more about the MongoDB Podcast, you can check us out on all major podcast platforms or visit us at mongodb.com/podcast. That's where you can get more information about the MongoDB Podcast. Today, we are doing a live version of the podcast. And once again, we're welcoming Jay Runkle. Jay, where in the world are you?
I am in Philadelphia today. So I did the first podcast in Philly. We're doing the third one in Philly. We made a brief detour to Florida last week.
Gotcha. All right. Welcome, Niraj. Niraj is hiring. If you're looking for a job, contact Niraj M. Looks like he's got some jobs available. Welcome to everybody joining us from India. Welcome to Mohammed from Paris. Mohammed Zahaf, great to have you joining us today. Today is the third, and I'm going to kill that music while we're at it. Let's turn that off. So today is the third in a series of 3. So we're culminating today in a focus on making use of the analytics and the data that was generated during a rocket launch. Jay, I'll let you introduce today's stream.
Sure. So just to kind of set the context, what we've been doing over the last couple of weeks is looking at the type of analytics you can build in MongoDB in real time, essentially while your app is running. So if we've been using this rocket launch as an example, so in the first week we looked at, you could use MongoDB Compass and write some aggregation queries to analyze your data as it's being loaded into the cluster. We also built a chart in MongoDB Charts to show how you could create visualizations to get kind of real-time view of your data. And then in the last week, what we did is we took that chart and showed how we could embed that into a React app so you could build an interactive dashboard that contains charts. And then we also looked at some other capabilities that are really useful, like Atlas search, so you can do more complex queries against your data. And then we also looked at Atlas triggers so that you can, as your data is coming in, you can write reactive code that does perform some task in response to the data as it's being ingested.
Great. Awesome.
So what we're going to do today, though, is we're going to pretend that our launch is over. So we successfully launched the payload into orbit. It's all over. Maybe we've retrieved our rocket, or maybe it just landed into the ocean or whatever. It doesn't matter. The launch is over, and now we want to do more in-depth analytics. So we have more time. So what that means is we can run more longer running, more analysis, in-depth processes, and we can also pull in multiple sources of data. So we're going to talk today about how you can use the Atlas platform to do these types of complex analytics.
Fantastic. Well, that sounds like a great expenditure of our time today. If you're joining us and you missed the previous podcast, you can get more information on the link on the screen, which is mdb.link/rocket, mdb.link/rocket. There's also a GitHub repository where Jay has put together a lot of resources there. I'd like folks to jump directly there. Yeah, there you go. You have it on the screen. So check out that GitHub repository. What can folks find there?
So pretty much everything that I showed during the live stream, written instructions, the links to the previous live streams, every slide I've showed, as long as any code or any configuration that I've made, a lot of capabilities of Atlas, when you go into the GUI and you make changes, it also has a JSON representation of that configuration. So I save those and put them into the GitHub repository. The idea is to make it as simple as possible for somebody to recreate everything that we're doing during the live stream.
Great. Okay, well, let's jump right into it. Remember, folks, stick around as we get about to the third of the way in, Mark. We're going to pause. We're going to ask a trivia question, and we're going to pick a winner at random. We'll have to connect with you either on YouTube or LinkedIn, so stay tuned for that, and get ready to answer some trivia questions as we get started. Go ahead, Jay.
So in order to stick with the theme of, hey, how we can do these longer running, in-depth analytics once the launch has been complete, we're going to look at three Atlas capabilities or products, I guess you could say. One is called Atlas Data Lake. The second one is called Atlas Data Federation. And the third one is called Atlas SQL, which does as you would expect. And I think, as Ashir mentioned, we will be writing SQL queries against MongoDB data by the end of this particular live stream. And we'll talk about how to do that. So just to kind of set the context and refresh everybody where we've been, what we have in our Atlas cluster is some data from a rocket launch. And we have two types of data in our Atlas cluster. We've got the actual raw metrics that were produced by the rocket during the launch. And then the second set of data is notes. So these notes can be generated by one of two ways. One is by engineers during the launch. As they're watching what's happening, they may enter a note and have a timestamp associated with that note so they can go back and review specific time of the launch and dig into maybe some anomalies that they saw. And the second one is we have machine generated notes, which we created last week via Atlas triggers that looked at the metrics coming in, and whenever they saw a metric that was out of bound, added a note so that somebody could go review the data later. And then what we did during the previous live streams is we analyzed this data using a number of different tools. One is MongoDB Compass, which we'll see again today, which is a GUI for developers to inspect the data in MongoDB, write queries, things like that. We built visualizations using Atlas charts, and we wrote complex queries using the MongoDB aggregation framework. What we're going to do today, though, is we're going to pretend it's post-launch, and we're going to essentially run analytics across our rocket data, but combine it with data from other data sources. And today we're going to use S3. So what we'll have, what you see in the live stream in a little bit, we have some weather data in an S3 bucket, and we are going to use a product called Atlas Data Federation to run queries across or join the rocket data with the data in the S3 bucket, essentially do joins across that. And then at the end of the live stream, we will also leverage a Atlas SQL, which will allow us to write SQL queries against that same data. So I'm going to write the same join query first in the Mongo query language, and then we'll write it again in SQL, and both of those will against the same set of data and produce the same results.
All right, this is mind blowing. Okay, so folks joining us, if you're not familiar with MongoDB, it is a document oriented database. It's different than relational technologies that you might be used to, Microsoft SQL, Postgres, Oracle, in that it's a document database, and it uses a MongoDB query language primarily to access and update. For CRUD operations, you use MongoDB query. What we're going to show you today is how you can leverage SQL to access, and I believe it's read only at the moment, right?
It is read only today.
Yeah.
Correct.
Okay. All right. So stay tuned for that. Take it away, Jay.
All right. So just before I jump into the technology, just want to mention that where the first 2 live streams, we consciously made the effort to ensure that everything we showed could be done using the free capabilities offered in Atlas. So if you go in, we talked about this last time or the first live stream, but you can go into Atlas and create a free cluster, an M0 cluster. And then all of the capabilities demonstrated in live stream 1 and 2 leveraged all of the capabilities that are free on M0 clusters. Today, in order to leverage Data Lake, Data Federation, and Atlas SQL, we do actually have to use an M10 cluster. That's the minimum. Obviously, you can use larger clusters as well. And so to allow the viewers of this live stream to take advantage and play around with these capabilities, we have available 100 $50 free Atlas codes available. If you deploy an M10 cluster, that's probably 3 or 4 months. That $50 will get you 3 or 4 months of time. So you should be in pretty good shape. The caveat here is you actually have to find the code. And the code is in the data set that we've been working with for the last 3 weeks. And one way to find the code, you could probably come up with some other creative ways, is to find the document that meets the following criteria. There's 2 attributes listed here. If you find the document where the sum of these 2 attributes equals that long number there, there's a field in that document that says Atlas code, and then you could just enter in that free code into Atlas and get 50 free credits. So good luck with that. If you use the Mongo query language, the expression operator will be your friend. That's kind of a hint, because you have to compare 2 fields in the same document, and the expression operator allows you to write queries where you can compare 2 fields in the same document. All right, so that's kind of the baseline. So have fun finding that, and then you'll be able to build everything I'm building today. So before we jump in the capabilities, I just want to review the data set that we've been working with. Right. So as those of you who have attended the previous live streams, in our Atlas cluster, we have a database called Launch Data. It has 2 collections, Rocket Data and Notes. The Rocket Data has a bunch of data that was generated by our Rocket, and there's a set of devices on the Rocket. In this case, this document was produced by the Truth device, and that generates a set of readings at a regular interval of time. And similarly, the notes that I talked about earlier, the textual notes, either machine generated or human generated, have a structure like this. They have a title and a notes body and some other metadata that describe the parameter and the time period in which the note was written. So that's the data set that we're working with. And now what I'm going to walk you through is how you can do complex analytics on MongoDB. In terms of, this is kind of more post-launch. So this is kind of things that'll happen in batch. So the first product we're going to talk about is Atlas Data Lake. And let me just kind of explain what it is before I set it up. So Atlas Data Lake is a way to essentially perform complex analytics over a large data set really affordably. And the way it works is it allows you to export backups of your MongoDB cluster into the data lake. So in this scenario, you can think about it. We've just successfully run a launch. All of the data from that launch is in our MongoDB cluster, but maybe we have another launch next week. So one solution would be, is we could upgrade our cluster, maybe add more disk space, or maybe add add more RAM or more CPUs or something, and just keep on loading more and more of the data as each launch happens into the cluster. And that would be a way to go, but that would get really expensive in an actual production system. There's 5-10 terabytes of data that were produced by an actual rocket launch. So you can imagine if we did 10-15 launches over the course of the year, all of a sudden we're talking about a really large cluster, and that's going to be expensive. So what we're going to do instead is, after each launch, we're going to take a backup, leveraging the backup capabilities in Atlas, and then push that backup into Data Lake. And then we'll just keep a backup copy of each launch in Data Lake, and then we can then do analytics over that launch, or maybe compare two launches, or pull data from Data Lake and other data sources to do more complex analytics. So pictorially, the way that works is, in Atlas backup, every, let's say, day, we're taking a backup. So, Monday, Tuesday, Wednesday, we've taken a backup. On Wednesday, we do a launch. And so our backup for Wednesday has all of our data from our launch. And then we can just push that backup into Atlas Data Lake. And now we've got all the data from our launch saved in a really affordable storage, but also in a format that makes it really easy to query and efficiently query. So essentially what's happening under the covers is, when we save the data into Data Lake, it's doing a number of things. One is, it is storing it on cheap storage. It's storing it in a way and organizing it so that it can quickly find the information. And then it's also building a set of additional indexes on top of that data. So analytical queries run really fast. Essentially what it's doing is pre-calculating a lot of things for, like, the parameters, the minimum and maximum values, averages, those types of things, so that when you go and run, a query that sorts and groups and things like that, most of those aggregates are pre-calculated, and it can generate its answer really quickly.
So is that because of the storage type, or is that because of some materialized view?
No, it's not the storage type, because under the covers it's S3, which is
just object storage.
It's just object storage. So really the secret sauce is essentially the way we format it and how we, kind of organize the data in the bucket so that we can navigate to the data that we need very quickly.
Okay, great.
Yeah, if you're interested in how Data Lake works, there's lots of other talks that are available online on how that works. I don't really have time to go into it. I'm really going to focus on how you actually set it up today. So this is kind of my Atlas homepage here. You've all seen this on previous live streams. The one thing I did, though, that, because it takes 5-10 minutes, I didn't want to devote that time to the live stream today, is I upgraded this cluster from an M0, which it was last week, to an M10, right? So all you would need to do, if you go in and you find the free Atlas credit code, you can add that to your account and then click the upgrade button, and that'll take you to a place where you can select, I want an M10 cluster, and then 5-10 minutes later, your cluster will be upgraded. You don't lose any data or anything like that. Everything's the way it was. You're just running on a more powerful cluster. So we have our aerospace cluster, and then I'm going to click on Data Lake here. And what we need to do is we need to create an ingestion pipeline. If you remember in my slides, we periodically pushed a backup copy from, our Atlas backup into Data Lake. So I need to set up that pipeline. So I'm going to go click Add Data Lake Pipeline, and then just pretty simple, fill out the form here, select the cluster, select the database, which is launch data, and then rocket data, which contains our data. And then I need to give it a name. So we can call this, live stream Atlas Data Lake Pipeline, and continue. And then it's going to ask us for a pipeline schedule. So, and you can set up a schedule where it happens every day, every Saturday, last day of the month. But what we're going to do today, because we're going to essentially want to push the data into Atlas Data Lake after every launch, we're going to want to do it on demand, because our launches don't happen on a regular schedule. So we'll just say on demand. And then the next thing it's going to ask us is, what are the fields that we most commonly query about? And this information is going to be used to help Atlas Data Lake store the data in a way to support our most commonly issued queries. So in this scenario, I'm going to say, we most often query by time. This is time series data. It's a rocket launch. We're often, drilling in. We want to see the data from a particular time period. And then the next most common field is the device. So just meta.device. And then once we fill that out, we can just say continue. And then the other thing it's asking us is, what data do you not want to move into Data Lake, or what fields? So if you can think about this as being like a banking or e-commerce application, you may not want to push the individual's name or social security number or credit card information into the Data Lake. If you're doing analytics, that's irrelevant and contains PII data. So you could exclude relevant fields. Now, with the rocket example, we don't have any PII data, so we don't have to add anything here, but we give you that capability. And then we just say finish, and we've now set up our pipeline. And then for this scenario, we're going to pretend that our launch just finished. So we're going to say trigger an on-demand pipeline run. So we're going to choose one of the backup snapshots. We'll take the most recent one, but it could be, depending upon when the launch occurred, we could pick whatever the most appropriate backup snapshot was and say confirm. And now what will happen in a background process is Atlas Data Lake is going to grab that backup snapshot and move it into its storage and organize it, build all those indexes I talked about. And in a few minutes, it'll be ready to be queried. So that's pretty easy setup. The next thing we're going to work on is, well, how do you actually query it? So let's do that. So the next component of this, if I go back to my slides, is we are going to set up Atlas Data Federation, because Data Lake is just a place to store information. The way you actually query it is via Atlas Data Federation and then Atlas SQL, which we'll get into a little bit. So okay, what we're going to set up...
This is massive. I want folks to understand this, because Atlas Data Federation, to me, it's absolutely mind-blowing. You're going to get what's essentially a virtual cluster address, right? It's going to be the virtual connection string to the Data Federation instance. But beneath that, you can have N numbers of actual Atlas databases, S3 object stores, data lake instances, even CSV, TSV, right?
It's actually HTTP. It'll support any HTTP endpoint as well.
So API,
so you could have,
so
you can have, you can have any number of 4 types of data sources: data lake, like you said, an Atlas cluster, S3 bucket, and then HTTP endpoints that you can query.
Right on. Awesome.
So and then like you said, the real powerful thing is it presents itself as a MongoDB server. So when we use Compass, we're going to use Compass just like we did when we were using an Atlas cluster. We're just going to write aggregation queries, send those aggregation queries to Atlas Data Federation. It's then going to push those queries to all of our different data sources and then aggregate the results and present them back to us. So, and like I said, for today, we're going to run a query where we join data from our rocket launch, which is in Data Lake, with the data that's in our S3 bucket. So this is the part where it gets a little complicated, and it has nothing to do with MongoDB. The issue is that we're reaching into an S3 bucket, and that means that we need to set up the permissions within our AWS account to allow Data Federation to read from our S3 bucket. So I'm going to quickly show you the steps to do that, so that my expectation is that at a later time, when we're not doing this in real time, you can stop the live stream and follow along. But I'll just walk you through the steps on what's required to set that up. So the first thing I'm going to do is just go into my AWS account. I may have been timed out. We'll see. And I'll show you the S3 bucket. See if it... All right, cool. And so I have a bucket called Rocket Data Archive. So we'll click on that. And then there is a folder in here called Solar Wind that has a bunch of solar wind data that is solar wind data that is from around the time of the rocket launch, right? So, because we're going to join this together, and one of the things we're going to join is based upon time. Joining, solar data with the rocket data from a different time period wouldn't make any sense. So what we're really trying to do when we run these queries is see, did any of the solar flare activity impact our rocket launch at all? Is really what the types of queries we'd be running here. So this is all of our data. It's just a bunch of JSON files. We'll look at it in a little bit. So what I'm going to walk you through now is how do I configure Atlas Data Federation and my S3 bucket so that they can talk to one another. This is really just a permissioning set of steps. So the first thing we need to do is go into my Atlas account and go to the project itself and click integrations and say I want to integrate with AWS IAM roles. So basically I need to configure my role in AWS to allow me to access this Atlas Data Federation, or the other way around is more likely, Data Federation to access my S3 bucket via my role. So if I click on view here, you can see I have one already set up. The way it gets set up here, though, is if I click on authorize AWS IAM role, it's really just, if I click on this, it's giving me the basic information I need, but more importantly, it tells you that you can set this trust relationship up in one of two ways. One is you can use the AWS CLI, or the other way is to just go into the GUI. So let me show you how you would actually do this. So this is the important bit of information you need, right? So we need that bit of information. If I go into AWS and click on IAM, and I knew that was going to happen. Hold on, let me just log up. It's very sensitive for how long you stay logged in.
It timed out, yeah.
Yeah, so let me go back to IAM here and click on roles and search for me.
Let me know when a good time to give folks the trivia question is.
Okay, all right, let me just finish this up. And then if I click on trust relationships, you'll see this is the exact same block of JSON that I just showed you. So all you would need to do is paste this bit of JSON into your role trust relationship tab here. So that's pretty easy. Just drop that in. So that's kind of the first step. We're going to have to do one other thing in a little bit, but that's kind of the first step. Mike, as soon as I finish this, that'll probably be a good time. So the other thing that we want to do is we're going to have to also set the permissions to allow access to that S3 bucket. And if you look at that, there's another bit of JSON that we need to drop in. And the question is, where does that come? So there's essentially two tabs that we need to make configuration changes. And so there's this bit of JSON that allows the, so the first one set up the trust relationship. This other bit says you can access this particular S3 bucket. So the way you set that up is you just do that as part of the process of creating the data federation endpoint. So if I go back to my cluster, and again, this is a lot of stuff. If you're not familiar with AWS, just the best thing to do is just click through this and stop it, pause it at a later time via, the YouTube video or the LinkedIn video, and just stop it and follow along. But anyway, now what we're going to do is create the data federated endpoint. So we're going to say, hey, we want to create a data federation that connects our S3 bucket to our data lake. So we'll create the data federated endpoint, and we'll begin to add data sources. And the first data source we want to add is that S3 bucket. So we'll do next. We'll say next to that. And it'll walk us through a little wizard. And you should have that role we just created that was authorized in the previous step. That should now be listed here. So you can click on that. And then you need to specify the bucket. So my bucket name is Rocket Data Archive, and the folder the data is located in. So Solar Wind here, and we do next. And now you get another bit of JSON, And that's the JSON that goes in that second tab here. So you can just drop that.
So that's going to enable data federation to access.
Right.
Yeah.
The first bit of JSON establishes the trust relationship between Atlas and your AWS role. And then this actually says you actually have, here's the AWS resource, that S3 bucket that you can have access to. And really, we're giving read-only access here.
Okay.
So that's really the steps that you're following. And then, so once we've done that, so you can do that via the GUI, just paste this in, or if you're a AWS command line user, this is the AWS command line statement that does the same thing as that GUI I just showed you.
But you'll have to
position. And then the next
JSON
thing you have to do is just type in the path. So it's just Rocket. So this is the S3 bucket name, Rocket Data Archive in my case, and then the folder, and we will be good to go. So now we've just established the connection from the S3 bucket and data federation. So I'm just going to clean this up just so we have call this Rocket Analytics. That's the name of our virtual endpoint. I've been using the name of the virtual database as the same name. It saves me from having to know different dialogues that ask you for different things. If they're both the same, it's easier. And then this collection, because it's our S3 bucket, is going to be weather. Right, so we got weather, and I can just drag that. And then now I can just drag in my S3 bucket here. And we've now said that we've got a virtual database whose name is Rocket Analytics. It has a collection called weather, and the data from that collection is coming from an S3 bucket. And the only other step, which is easier, is we just need to add the data lake here. And this is our data lake pipeline that we just created. And so
notice you didn't have to do anything for that data source to appear.
All I needed to do was, I could just do all data sources. That's probably simpler. It shows me all the data sources. Or if you have a lot of them, you can filter by type. But these are the 4 types we support.
Great.
And then all I need to do, what I'm going to do here is create a new collection in this virtual database. And I'm going to call it historical data. And do create. And then I can just drag in my pipeline into there. So now what we have is we have 2 collections. This one's tied to an S3 bucket, and this one is tied to the data lake. And and then finally with the pipeline, it will give me a number of choices here. Do you want the last backup, or do you want a list of all the backups? So essentially what it will do is create a collection for each of the backups. I'm just going to go with latest to make things simpler. So the latest backup that we've pushed to data lake, its data will populate the historical data collection.
Great.
And then I can just do save, and we've now created that pipeline. And there's a good place to pause, and then what we'll do next is actually work with the data itself.
Okay. All right. So this is a great, very timely trivia question. Which feature, okay, folks, listen up. This is the trivia question for the day. You can win a lovely MongoDB podcast t-shirt. What feature in Atlas enables you to have a virtual cluster address that is backed by S3, Atlas Data Lake, Atlas clusters, and even HTTPS API endpoints? We're looking for the name of the feature that is in Atlas that enables you to create virtual clusters that are backed by all of those different data sources. So you get a single virtual MongoDB connection address that is backed by multiple. I love the fact that you can have multiple clusters backed, front-ended by this single connection string. So if you know the answer, go ahead and put it in the chat. Looks like we've got a lot of B's. Okay, so we're gonna select somebody at random, and I'll contact you over LinkedIn. Watch for my connection request. Anurag again. Anurag has been on a couple of these live streams. Awesome. It's good to see you again. Yeah. All right. So let's continue. I'll get back to you with the winner shortly.
So we just built our data federation virtual endpoint. actually, the one thing I forgot to show, which I'll show right now, is we just built that virtual endpoint via the this GUI configuration we just saw. There's also a JSON view of the same data. The reason why, and so you can see that there is a JSON description. The reason why I think this may be helpful is I put this JSON description in the GitHub repository. So if just in case you follow along in the live stream and you set this all up and it doesn't work, you can go back and compare your configuration to the one I used and maybe find the problem. So that's just useful information to have. So that's all good. So what we've built is this Rocket Analytics Data Federation. So how do you actually work with it? If you remember, like Mike said, it looks, when you work with Data Federation, it emulates a MongoDB cluster. So you work with Data Federation just like you would work with any MongoDB database. And you can see that there is this green connect button. So we'll click on that, and we're going to try and connect to it via Compass. And it gives us the connection string. So just like any other MongoDB database, we'll copy the connection string, and then we will open up Compass and say, new connection, and paste that connection string into the window here. And then we'll put our username in here. So in my case, it's demo. And I'm just going to move this off screen here so I can put my password in. And then we will I'll rejoin with my password in there. All right, so I entered my password and pressed connect, and you'll see now we have we're back into Compass, and we're connected to the Rocket Analytics Data Federation. We have that Rocket Analytics database there, and if I open that up, we have the two collections that we showed. And if all goes well, we click on weather, and this is the data that was in those JSON files you saw in the S3 bucket, presented to us as documents. And so you can see that there are different types of, just like with the rocket data itself, there are different documents in here with different types of solar data about the sun, or at least the sun radiation. And similarly with the historical data, if this all went well, and it didn't, but usually it's just a matter of that finishing. We should also have access to the data in Data Lake. So let's just go back and make sure all is good with our Data Lake here. So if we go to Data Lake and we click on this pipeline, yeah, so it's still in process. So we need to give it, my practice in running through this, it happened pretty much on time here. So any good jokes, Mike?
Let's see. Not appropriate for live streams.
All right, so let's just assume that that's working, and I'll show that in a second, and we'll start to build our query, and hopefully by the time we get there, that will be done. So in a minute, you'll see the same data we've been working all along once that export to Atlas Data Lake is complete. So what I want to do is build a aggregation query that joins the data from the historical data collection to the weather data, right? So, and we're going to write an aggregation query and use the MongoDB $lookup operator. So if we go to, let me just try and do a find again, see if we have success. No, we do not. So we're going to go into the aggregation framework here, and we're going to use a little bit more of a advanced features. Last time we used the query builder. This time we're going to work with the query as text. This allows me, just for this live stream, to cut and paste some more complex queries here. And our query that we're going to do is going to consist of a match where we're going to select some of the launch data, and then a lookup where we're going to join that launch data to the weather data. So if I go ahead and start to set up that query, we'll do the match. And we'll just drop that in here.
Okay.
And the idea behind this is success. All right, cool. So now let me just show you the so our export to data lake has completed. So just to kind of prove that to you, if I refresh this now, it should say that our export is complete. So ingestion is done. So we're all good there. And if I go to this historical data, you can see that we're now looking at the same rocket data that we were looking at before, except now we're talking to data lake instead of our Atlas cluster, and we populated data lake by using a backup snapshot of our Atlas cluster.
Beautiful.
And then if you look at my query that I just started to write, all I'm saying is I'm only interested
That's really
in
small.
LiDAR.
Can you command
I
plus that a little
can,
bit?
yeah, I can make this bigger, sure.
Okay. I'm gonna get to your question, Anurag, shortly. Hang in there.
So what you can see is we essentially added a match, which is a filter, and we're saying we only care about data from the LiDAR devices that was produced after a particular time period. You can imagine that we've looked at the launch data and there seems to be something that went wrong or strange around this particular time period. So we want to filter out all of the other data except the relevant data. And then what we want to do is we want to join this data with the solar data from around the same time period, right? So if you look at this, each one of these is from a LiDAR device, and the timestamp is greater than the value that we've put here. So the next piece of this is to add the dollar lookup, which is the MongoDB essentially join operator. And just going to cut and paste that from another window and drop that lookup code into here. And now I want to kind of walk you through what I'm doing. So here's the lookup operator. This is the collection we're joining to, right? So we're starting from the left-hand side of the join is the historical data collection. The right-hand side is the weather. And then this let statement is just a way of calculating some variables. It just simplifies our code because we're creating some variables. So we create a variable called time low, where we're taking the time of this particular reading and subtracting 60,000 milliseconds or 60 seconds. So we're subtracting a minute. And then we're creating time high by taking that same time value and adding a minute to it. So you can think about it where for each reading, we're creating a window of 2 minutes, 1 minute on each side of the reading. So we've got that low and high value. And then we're running this pipeline. So we're writing a second aggregation query, but this pipeline is going to run on the weather collection, and it's going to extract out the documents that we want to join to the current document. So we're doing a match here, and then we're matching for all of the documents that in the weather collection that have the metric or the type of plasma 7-day and whose time value is greater than the low variable and higher than and less than the high value. And those values get written to the result field. So if we look at the result field here, it now has a set of documents in it, each one of them being a weather reading associated with the plasma 7-day data set with a time value that's within 1 minute of the reading of the rocket data that we're working with. So essentially what you end up with is we selected 3 documents by the match, and then each one of those documents now is associated with the plasma 7-day readings that are around the time period for that particular LiDAR reading.
Great.
So that's how we can join the data. And that's how we can do that join using data federation, using the Mongo query language. What we're going to show next is how we can do it in SQL.
Hold on to that one. I want to address Anurag's question. Does the type of data matter in S3? For example, if we have data in tabular form, would it?
Yes,
would it be
great question, which I should have mentioned and I did not. So thank you for asking that. So yes, it does. We support. Let me see if I can get most of them. So CSV, TSV, JSON, obviously, Parquet, Avro.
Parquet.
Yeah, Parquet, that's a really common one.
Yep.
compressed or not. We support both versions. Yeah, I've worked with a lot of customers that have Parquet data in S3. That's pretty common format if you plan to run analytics against it. So yeah, having us support that is really valuable with Data Federation.
Okay. So, and for playing along and having the right answers, we selected 2 winners at random. Leo, Cherry, and Jacob had the right answer. Atlas Data Federation enables you to have a virtual cluster IP address backed by S3, by HTTPS API endpoints, as well as data lake and Atlas clusters. And Anurag had the right question, had the right answer as well. So those 2 guys got T-shirts. Thanks so much for playing along. Continue, Jay, and then we're gonna have one more question at the end of the stream today. We'll give someone else a chance to win.
Excellent. So I'm going to write this same query in SQL and show you how you can run this in SQL. Now, Compass doesn't support SQL, so we have to use something else. So I'm going to use a open source tool called dbeaver. But essentially, any tool, any SQL compliant client should work. You can use a command line tool.
Wait a minute. So MongoDB is now queryable via SQL?
Yeah. So the picture. I know it's crazy. The picture is I drew a picture. I should probably show it. Is this one here? So we have a product called Atlas SQL, and that it sits in front of Data Federation and converts the SQL queries into aggregation queries, and then passes those to Data Federation, and it works. Data Federation works as it always has.
So I don't have to export my data and do an ETL and have a massive lag between the batch jobs so that I can run my SQL jobs against MongoDB data?
Nope, you don't have to figure out how to shred your documents into rows and columns and do all that and ETL it. Nope, you don't have to do that. You can just query it as it exists in JSON or MongoDB or Data Lake or what have you.
All right. So the question I invariably get from customers when this is mentioned is, can I do this on-prem? Can I do this? Can I run SQL statements against my MongoDB data on-prem, not in Atlas?
So Atlas SQL today only runs in Atlas. So the data would have to be in the Atlas platform to do that.
Because if you think about the architecture, there is a transpiler for your SQL statements, which in real time is converting that to MongoDB query.
Yeah, and we're deploying, these Atlas SQL and Data Federation run on a set of app servers. We're deploying those on your behalf when you use Atlas SQL. So
great. Okay.
All right. So let's talk about how you do this. So there's one step that I'm not going to show today, but if you go to the GitHub repository, if you look at the bottom of the README for live stream 3, it talks about how there is a JDBC Java jar you need to add to a directory in dbeaver to make this work. It's probably in any tool that you are going to use to connect to Atlas SQL via JDBC. There's probably a jar file you need to use. So if you want to use dbeaver or any other client, you go look at that link in the README, and it'll talk about the jar file, where to find, where to download it from, and how to install it. So I have that step already done. I didn't want to kind of bore everybody with kind of those mechanics today, but once you've added that plugin to dbeaver, the rest of it's pretty straightforward. So the first thing we need to do is we need to go to Data Lake, and not Data Lake, to Data Federation, and click on the connect button for our endpoint. And this, where before we selected Compass, now we want to select connect with Atlas SQL. Right, that's kind of key. And then the other thing is the mistake I always make, and I've practiced this live stream like 3 or 4 times, and I did it almost every time, is select basically JDBC. If you want to connect via Tableau, use the Tableau connector. But if you want to connect via JDBC, then make sure you select JDBC, because otherwise it doesn't work.
Yeah. I don't think it should default to. I think it should default to JDBC.
JDBC, yeah. So I've made that mistake lots of times. So basically, just copy this connection string. That's pretty easy. All right, and we go back to dbeaver and have to create a new connection. So new database connection, and then if you did the setup correctly, so if you didn't add the jar file, then you won't have this gray button called MongoDB. So by going through that setup process I mentioned and dropping in the jar file in the right place, that adds the MongoDB icon there. And then you do next, and then you can just put your connection string right in there. So that's pretty easy. And then just you add the same username and password that you've been using all along. And if I type that correctly and we do finish, so now that adds a little MongoDB connection. And the proof is when we go connect. And if all goes well, so we now get a little green check mark. So that's good. So we now have our SQL connection to our Atlas Data Federation endpoint. And if we open that up, you'll see it has one database. And if we look at the tables, we've got two tables here, as we would expect. And then I can go and do Open SQL Console. And everybody goes, select asterisk from historical data, for example. And we go ahead and run that. And you'll see what you get is just you're going to get a bunch of rows that correspond to the Rocket data. Now, again, because there's documents, and if you remember from the first live stream, not all the documents have the same set of fields. So it is essentially a sparse schema, but you get all of the data. And we can do the same thing, select asterisk from weather, and you run that, and you'll get all of the weather. You get this essentially all of the data from that collection. And then that same join, I'm not going to bore you with typing it, but I'm going to go grab the SQL query here in another window and paste it into the into dbeaver. Again, the query is in GitHub, so don't need to take a screenshot or anything. You do a query, and now we're doing that same join. If you look at this, we're doing an inner join between those two collections, and I've got the data restricted by the same date range. And at the end of that, we get the same set of rows that we saw within Compass using the Mongo query language. So that's all there is to it. Once you've got the data federation endpoint set up, you're just working with SQL if that's what you're comfortable with. Before we run out of time, there's one problem I ran into. I just want to show you how to get avoid it if you are doing this yourself. Sometimes when you do select asterisk from historical data or select asterisk from weather, you'll run it and you'll get an error saying there's no schema on the endpoint. If you get the error saying there's no schema, that's and I haven't figured out why, but sometimes Data Federation and Atlas SQL don't create a schema for whatever that endpoint is automatically. But that's not a problem. It's really easy to create the schema. So if I go to Compass now, and I'm connected to the Data Federation, and just open up. I don't know if you've used Compass before, but it has the Mongo shell at the bottom. What you can do is you can go, use Rocket Analytics. So we're just going to that particular database, and if we do show collections, you'll see that we have those two collections, and then you can just ask them, "Hey, do you have a SQL schema?" So if we go to, just grabbing the command here. So I can just go here and say, do you have a SQL schema? And it does. Well, obviously, my thing just works, so it did. And obviously, we'll get the SQL schema for the other collection. But you may get.
Can you make that a little bigger? I can't see that.
You can't see it. All right.
Yeah, there we go. So you're doing a db.run command.
db.run command get
SQL get
schema, and then this is just the name of the collection.
Yeah. Okay.
And so we get a document back, and it has a schema and all that stuff. So we're good. So if you get an empty document back, you don't have a schema, and then that's obviously an issue. So the way you can get around with that is you can just switch to the admin database, and then run a command like this, which I'll show you. We're just going to recreate the schema. And essentially what this does, it's just called...
for the folks listening, explain what that command was.
Yeah, I'm going to. So basically the command says SQL generate schema. So we're generating a schema. This is the collection I want to run the schema on. So in order to run this command, you have to be in the administrative database, because this is kind of changing the schema on a collection is a pretty significant change. So we need to be in that database. And so we're just identifying, here's the database and the collection we're creating the schema on. And the way it generates the schema is it grabs a random sample of documents from your collection, looks at all the fields on that random sample, and then based upon that automatically generates the schema. So it's gonna, depending upon whether types of the fields and whether they have arrays and subarrays and things like that. So you want to pick a number that is guaranteed to get all of the variety in your database, but not too big, otherwise it takes a really long time. So you want 1,000 tends to be a good number, but if you had a collection of 1 billion documents and there was lots of variety, 1,000's probably not big enough. So you have to kind of pick a number rationally, and then just set schema to true. And by running that command, it will add a schema to your collection. So if you are using dbeaver or some other SQL client and you get a no schema available error, you can go in and build the schema manually. There are, just as an aside, there are commands. If you want to programmatically define the schema, like you want to specify every column and every type, and we give you that. There's a commands for doing that as well. So if you want to, if you know your data and it has these 28 fields and you want to specifically, not have us generate it, you want to define it, you can do that also.
That's great. And that solves the problem, the gap between a document-oriented database like MongoDB that supports polymorphism and one that doesn't,
correct.
Tabular.
Absolutely.
Okay.
Yep.
All right. So we get time for another trivia question?
Sure, let's do it.
All right. Timely as well. What feature enables you to run SQL commands against MongoDB data? A, dbeaver, B, SQL Enterprise Edition, C, Atlas SQL, or D, MongoDB Compass? If you know the answer, put it into the comments. If you're logged in as an anonymous user, I won't be able to contact you. You'll have to figure out how we're going to get connected, but I've been reaching out to folks on LinkedIn. If you're a YouTube user and you want to answer the question, you're going to have to reach out to me because I can't contact you via YouTube. But if you want to win a MongoDB t-shirt, a MongoDB podcast t-shirt, go ahead and put your correct answers in the chat. What feature enables you to run SQL commands against your MongoDB data? dbeaver, SQL Enterprise Edition, Atlas SQL, or Compass? All right. I'm getting a lot of good answers here. Here we go. Yeah, good stuff. Okay, so we're gonna select somebody at random, and I will reach out to you. The correct answer, by the way, since we're coming up on time, is C, Atlas SQL. Thanks for playing along.
So this whole live stream has worked like clockwork, Mike. We're at the end. We've built our Rocket data. We know how to do analytics in the launch. We know how to do analytics post-launch. So I will, as soon as the live stream is available, I'll add this live stream to the GitHub repository, but I encourage everybody to go to the GitHub repository and create their Atlas account and try everything. I think once you kind of get the hands-on experience, you learn how easy it is and kind of the whole power of the platform.
Yeah, right on. Well, thank you so much for putting all of this together. It's been a great learning experience for me. I want to put the links back up real quickly. So there's a link here, mdb.link/rocket. You can get information about the previous live streams there. We'll include links. And then, of course, one of the most valuable links that we have is a link to the repository where all of this stuff lives. Great. Well, Jay, anything further to add before we wrap?
Nope. This has been great. I hope we get to do it again real soon.
Absolutely. Yeah. Hey, and subscribe. Let us know what you think in the comments. And listen to the MongoDB podcast. You can find us on all on all podcast networks. You can find me on Twitter at mlin, and hope to see you soon. Thanks, everybody. Have a great day.